Continuous extract ventilation is one of those Part F topics that sounds straightforward at first. Fan runs continuously, stale air gets pulled out, problem solved. But in practice, a lot of junior engineers misunderstand what the system is actually trying to do, what rates matter, and how it connects back to the rest of the dwelling ventilation strategy. By the end of this video, you'll understand what continuous extract ventilation is, where Part F uses it, what the minimum rates look like, and the design mistakes that catch people out. Let's start with the principle. Approved document F says extract ventilation can be intermittent or continuous. Continuous extract means the system runs all the time at a background rate, with the ability to increase to a higher rate when needed. So unlike intermittent extract, which switches on only during use or on demand, continuous extract is providing an ongoing removal of stale air and moisture from wet rooms. That sounds simple, but the important thing is this. Continuous extract is not just about one fan in one bathroom. It is part of a wider dwelling strategy. Part F says a continuous mechanical extract ventilation system could consist of a central extract system, individual room extract fans, or a combination of both. So when you hear continuous extract, do not picture only one specific product. Think of it as a strategy type. Now let's look at the rates, because that is where a lot of the confusion sits. Table 1.2 gives the minimum extract ventilation rates for continuous extract systems. The minimum high rates are kitchen equals 13 liters per second, utility room equals 8 liters per second, bathroom equals 8 liters per second, sanitary accommodation equals 6 liters per second. And then the document says something very important. The sum of all extract ventilation in the dwelling on its continuous rate should be at least the whole dwelling ventilation rate given in Table 1.3 and paragraph 1.20. That is one of the biggest junior engineer takeaways from this topic. You are not just checking the local high rates in individual wet rooms. You are also checking that the total continuous background extract across the dwelling is at least equal to the whole dwelling ventilation requirement. That means continuous extract ventilation has two layers of thinking: local wet room high rates, total dwelling continuous rate. And if you only check one of those, you can miss the real requirement. Now, what about background ventilators? This is another area people get wrong. Paragraph 1.64 says that where continuous mechanical extract ventilation is used, background ventilators should not be in wet rooms, but they should still provide a minimum equivalent area of 4,000 square millimeters for each habitable room in the dwelling. It also gives a minimum number of ventilators equal to the number of bedrooms plus 2. So continuous extract does not mean background ventilators disappear. It changes the requirement, but it does not remove it. And this is why people can misread the strategy. They assume that because the extract is mechanical and continuous, the supply side somehow takes care of itself. But Part F is still asking you to think about the air route through the dwelling. That includes internal transfer too. Just like with other dwelling strategies, internal doors need to allow airflow through the home. If the doors are too tight, if the transfer path is ignored, or if the system is designed as isolated room-by-room points without a proper air movement strategy, then the overall performance may not match what the drawing suggests. Now let's talk about common mistakes. Mistake number 1 is remembering the high wet room rates, but forgetting the whole dwelling continuous total. Mistake number 2 is putting background ventilators in wet rooms when the guidance says they should not be there for this system type. Mistake number 3 is thinking continuous extract is the same thing as MVHR. It is not. MVHR has mechanical supply and extract, whereas continuous extract relies on background ventilators for supply into habitable rooms. Approved document F treats those as different strategies. Mistake number 4 is ignoring external conditions. The document says if an exhaust air terminal is on a facade exposed to the prevailing wind, measures should be taken to minimize likely wind effects. It even gives example solutions such as ducting to another facade, constant volume flow units, or seeking expert advice. That is another useful junior engineer point. Part F is not only about the fan rate on paper, it is also about whether the installed system can work properly in the real building. So the simplest way to remember continuous extract ventilation is this. It is a continuously running extract strategy for wet rooms. It has local high rate requirements in Table 1.2, a total continuous extract requirement that must meet the whole dwelling rate, background ventilators in habitable rooms, and an internal air transfer path that still needs to work. Once you see those pieces together, the system makes much more sense. This video is based on approved document F Volume 1, 2026 edition, so always check the full guidance for project-specific compliance. If this helped, subscribe to The Lazy Engineer. And if you're working through the Part F series, watch the videos on purge ventilation, trickle ventilators, and common Part F mistakes next, because they all connect back to this wider residential ventilation logic.